So from the lecture, that you know that the ear can be divided into three parts, and you have the external ear, which include the pinna, yeah, or the ear auricle, and then you have the external auditory meatus or the external auditory canal, and you also have the tympanic membrane. The tympanic membrane. The tympanic membrane is actually forming the boundary between the external ear and the middle ear. Yeah, so sometimes it is classified as a structure which is a part of the middle ear structures. Okay. The first one, the auricle, yeah, is composed of the parts of the pinna. Yeah, so in your ORL posting, yeah, in future, maybe you need to be able to identify the specific parts of the auricle. Yeah, so among the important ones are like the lobule, yeah, which is not entirely visible, yeah, in this model, but it is the part in which the ladies you wear your earring, yeah, and then you have the tragus, which is on the located on the anterior part of the ear auricle, and then you have the antitragus, yeah, and then you have the helix, and then the antihelix, yeah, and then you have the fossa, the concha, which you can refer in my lecture notes, yeah. So the ear pinna, yeah, it has elastic cartilage, yeah, in its structure, except the lobule, yeah, where you don't have any cartilage. All right, and then the external auditory meatus, yeah, this is an S-shaped structure. Yeah? So because of the S-shaped structure, if you perform otoscopic examination, that is why sometimes you need to pull up the ear pinna in order to straighten up the meatus so that you can directly see the tympanic membrane. Yeah, tympanic membrane. In the wall of the external auditory meatus, you can see plates of cartilage, yeah, like in this model here. So this shows the uh, elastic cartilages that are present in the wall of the external auditory meatus. The lateral one-third or lateral two-third of the external auditory meatus, yeah, it has this elastic cartilage, whereas the medial one-third, yeah, of the external auditory meatus, it is lined by bony structures, yeah, bony structures. And there is a little bit of constrictions, yeah, which is known as isthmus. Yeah, that is the sort of like the narrowest part of the external auditory meatus, and it is located about 5 millimeters in distance from the tympanic membrane. Okay, and then next we have the tympanic membrane. Yeah, the tympanic membrane is concave, yeah, on the external surface. Yeah, concave on the external surface, and actually on the surface of the external surface, it is lined by thin skin, yeah, like thin skin structure, and the tympanic membrane, yeah, on the inner surface, yeah, it looks like a convex structure, a convex structure, yeah? And you can see the uh, attached handle of malleus, yeah, on the internal surface of the tympanic membrane. Okay, now we arrive at the middle ear cavity. Yeah, the middle ear cavity, it is a can be described as having like 6 walls or 4 walls with a roof and a floor. Yeah, so the detailed structures, yeah, are not seen in the model, yeah, but in the diagram probably it's easier for you to identify all those structures that are present on the specific walls of the middle ear cavity. The middle ear cavity is also known as the tympanic cavity. Yeah, tympanic cavity. Among the structures that are located in the tympanic cavity, yeah, are the ear ossicles. Yeah, so you can see the malleus, the malleus, and then you have the incus, which is located in this case like hidden behind the malleus, and then you have the stapes, stapes, the malleus, incus, and stapes. All right, and then you can also see this whitish structure, which actually refers to the the tendon of the tensor tympani, tendon of tensor tympani muscle, tendon of tensor tympani muscle. Maybe it's a bit difficult for you to look at this structure because it's okay. Fine. Okay. Yeah, so this is the tendon of the tensor tympani. The tendon of tensor tympani, is actually attached to this part of the muscle. This is the tensor tympani muscle, part of the tensor tympani muscle. The tendon of the tensor tympani muscle is attached to the neck of the malleus, the neck of malleus. Okay. Because the ear ossicles are quite small, in this model, maybe it's a bit difficult for me to show you the exact position and parts of the each of the bony ossicles, but you can refer to the lecture note. For example, like the malleus, malleus, it has several parts. It has a head. This is the head of the malleus, and then it has a neck, and then it has the anterior process, anterior process of the malleus. It has a handle of malleus, and you can see that the handle of malleus is attached on the internal surface of the tympanic membrane, and then the tip, right at the tip of the handle of malleus, this is actually where from the outside you identify as the umbo, the umbo, in your otoscopic examination features. And then it also has a lateral process, which is a small process, that one there, lateral process. Okay, and then the head of malleus, on one side it has an articular surface with the body of the incus, incus. So this is the point of articulation, between the head of malleus and then the body of incus. And then with regard to the incus, it has a long limb. This is the long limb of the incus, and it has a short limb, the short limb of incus. Okay, and then right at the tip of the long limb of incus, that is where you have the lenticular process, lenticular process, in which that structure articulates with the head of the stapes, the head of the stapes. Okay, and then the stapes, you have the anterior and the posterior limbs, the limbs of the stapes, and it has a foot plate or the base of the stapes, the foot plate or the base of the stapes. And the foot plate or the base of the stapes is actually the structure that close off the oval window. So if I detach that stapes bone, from the vestibule, of the inner ear, you can see the side of the oval window, the oval window. Okay. Okay. So within the tympanic cavity, you can also see the extension of the posterior wall, yeah, where it forms the antrum or entrance into the close to the mastoid process. Yeah. So posteriorly, that is where you have the air cells, of the mastoid part of the temporal bone. Uh. So this is the antrum of the mastoid, mastoid antrum, mastoid antrum. And actually the cavity, the tympanic cavity is divided into two parts. You have the tympanic cavity proper, and then you also have the epitympanic recess, which is located more towards the roof, superior part of the tympanic cavity, epitympanic recess. Okay, so I cannot show you a lot of other structures that are present in the middle ear cavity, especially in the medial wall of the tympanic cavity, in which you have a lot of structures, in that part of the wall. But uh, remember that it has like four walls and a roof plus a floor, or you can describe as having six walls altogether. Yeah. So simply you can refer to the side, like anterior wall, posterior wall, lateral wall, medial wall, superior wall, or the roof and the floor. Yeah. Or you can refer to name of the walls according to the structures, the structural name, the structural name, like the tympanic wall, the jugular wall, the mastoid wall, and so on. Okay, right. So and then from the middle ear cavity, you can see this opening, this opening, the tubal structure. So this opening is the eustachian tube or pharyngotympanic tube. Pharyngotympanic tube or eustachian tube. It forms communication between the middle ear cavity and the nasopharynx. Where about in nasopharynx? If you still remember in your lecture on the pharynx, you have the torus tubarius, and then in the nasopharynx, just anterior to the torus tubarius, you have the side of the opening of the eustachian tube in the nasopharynx. Yeah, that's where it opens. So as you know, this tube, it functions as a communication, between the atmosphere and the middle ear cavity, so that you can equalize the pressure between the middle ear cavity and the atmospheric pressure. Whenever, for example, when you uh, go on high altitude, or when you go on an aeroplane, where there are changes of pressure inside the between the atmospheric pressure and the middle ear cavity pressure. Okay, and then moving on from the middle ear cavity, you have the part of the internal ear, part of the internal ear. So inside the internal ear, this is where you have the presence of the vestibular cochlear apparatus, vestibular cochlear apparatus. Okay, so remember that I mentioned about the bony labyrinth and the membranous labyrinth. Bony labyrinth and the membranous labyrinth. So bony labyrinth actually refers to the bony structure. The bony structure. Either the cochlea, the cochlea. Inside the cochlea, that is where you have the membranous labyrinth. You have the cochlear duct inside. Inside the cochlea, you have cochlear duct. So the cochlea is the bony labyrinth, whereas the cochlear duct, is the membranous labyrinth. Yeah, and then you have the vestibule. This is this part here is actually the vestibule, where you can see the ends of the semicircular canals are attached to. So the vestibule, this is the bony labyrinth, whereas inside the bony labyrinth, That's where you have the ventricle and saccule as the membranous labyrinthine structures. Yeah, so inside the vestibule, which is the bony labyrinth, you have the ventricle and saccule as the membranous labyrinth structure. Yeah, and then you have three semicircular canals. Yes, three semicircular canals. Um, so the canals are actually the bony labyrinth structure, and inside the canal you have the duct, the semicircular ducts, semicircular ducts. Okay, how to identify the semicircular canals? Yeah, you have to orientate yourself to the side of the ear that you are looking at. Yeah, since this model, yeah, is the left ear, yeah, the left ear. So the semicircular canal, yeah, that is like pointing or going towards the ear auricle or the ear pinna, yeah, that is actually the lateral, yeah, the lateral. So you can identify this semicircular canal as the lateral semicircular canal or the horizontal. Yeah, you can also refer to the orientation of the semicircular canal. So you can call this as the lateral semicircular canal or the horizontal semicircular canal. And then you have the one that is projecting towards anterior or superiorly. Yeah, so you can identify this as the anterior semicircular canal or the superior semicircular canal. Yeah, that is projecting like anteriorly or superiorly. Yeah, and then you have another one which is located on the posterior side. Yeah, the posterior side. This is known as the posterior semicircular canals, uh, and uh, you can see that the orientation, yeah, between these three semicircular canals are at right angles to each other. Yeah? This one here, the lateral semicircular canal, is in a horizontal position. The superior semicircular canal is in a vertical position, and then the posterior semicircular canal is at right angles to the lateral and the uh, superior semicircular canal. Yeah, so that are at right angles to each other. Yeah, because of that, it can detect the movement of the head at three different like axes of movement. Okay, um, and you can identify that the ends of the semicircular canals, yeah, like the anterior semicircular canals, yeah, on the anterior end, yeah, it opens into the vestibule, and then for the lateral semicircular canal, yeah, both ends, yeah, opens directly into the vestibule, and for the posterior semicircular canal, probably better for me to just take this out, yeah, and then I do it like this. And this is the posterior, yeah, the posterior semicircular canal. One end of the posterior semicircular canal, it opens directly into the vestibule, but you can see that for this one here, this is actually a union or a combined uh, part of the from the anterior and the posterior semicircular canals. They join and form a common like opening into the vestibule. Yeah? So altogether you have five openings into the vestibule, yeah? Because of the union of the one part of the anterior and the posterior semicircular canal into the vestibule. Okay, and then you have the okay in this model also. Yeah, if I can show you, you know, quite blur, but that is the part, yeah, which is indicating the location of the round window, yeah, or the secondary tympanic membrane, yeah, the round window. Yeah, remember the oval window is closed off by the base or the footplate of the stapes, yeah, but the round window is the part that is not related with the stapes. Okay. Now, for this model, I think I can also open the cochlea. Open the cochlea. Okay. All right. So if I open up the cochlea, yeah, so it shows the histologically, yeah, because these are microscopic structures. Well, it is not really showing the three compartments, yeah, in the cochlea. Yeah. Supposedly you have the scala media, scala vestibuli, yeah, uh, inside the cochlea. Yeah, but I cannot show here because it's not shown in this model. Yeah. But extending from the cochlea, you can see the cochlear nerve. The cochlear nerve. This is part of the cochlear nerve, and then this part here is the vestibular nerve. The vestibular nerve. So together they will exit as the vestibulocochlear nerve. The vestibulocochlear nerve from the internal uh, auditory meatus. Internal auditory meatus. Okay. If I put this back, on the model, okay, the cochlea it forms like 2.5 turns, 2.5 turns. So like this one. Uh, right. So the first turn is known as the basal turn, the basal turn of the cochlea. That is where it forms a bony projection on the medial wall of the tympanic cavity, yeah? So, which is known as the promontory, the promontory, which we cannot see in this model. So because of the basal turn of the cochlea, it forms a projection on the medial wall of the tympanic cavity, which is known as promontory. And then this is the second turn, and another half turn. And before it forms the apex of the cochlea, which is known as cupula, the cupula. Right? Okay. Okay. If I turn this model around, this is actually the side for the opening of the internal auditory meatus, through which the vestibulocochlear nerve exits. And apart from the vestibulocochlear nerve, you also have labyrinthine nerve as well as facial nerve, facial nerve. Sorry, labyrinthine artery. You have vestibulocochlear nerve, facial nerve, labyrinthine artery. Okay. Um, right. Other related structures that I can show you in this model are like the internal carotid artery. Yeah, this is the internal carotid artery, and you also have this one muscle, which is the pharyngo tympanic muscle. Yeah, pharyngo tympanic muscle. The pharyngo tympanic muscle. Yeah, it also helps with the uh, opening of the eustachian tube. Eustachian tube. When you, for example, when you yawn, when you swallow your saliva, in order to open up the eustachian tube, for short duration of time.